Good evening, and welcome to the third Selborne College and Old Selbornian Association webinar as part of our 150th Jubilee celebrations. My name is Gwanele Mgolozeli. I'm the head of the subject for physical sciences, and I also teach natural sciences at the college. The theme for this webinar is science and research. We'll get some thoughts from Old Selbornians who are in the field of science and research. It will be a discussion that is focused for boys who want to venture or have interests in the careers of science and research. Our panelists will share their experience about what they've learned and what they wish they knew earlier in their careers, and any other advice they might actually have for the boys, the audience. First panelist is Mr. Saravanan Ayugaswaran, matriculated from Selborne College in 2006, then did his BSc in engineering and measuring in mechatronics, robotics, and automation engineering. He completed an MSc in smart systems engineering from Lancaster University in the UK, as well as an MBA in Inside Business School. He started his career working as an engineer for Sasol before joining the Boston Consulting Group. And then in 2020, he joined Google, where he is currently the strategy and operations manager at Google in the UK. Mr. Ayugaswaran unfortunately could not join us in person this evening due to the current status in the Ukraine, but he has kindly shared a video with us with all his experiences and what he wants us to know about his field.
Hi everyone, my name is Saravanan Yogaswaran and I matriculated back in 2006. I'm super excited to be contributing towards Selborne's 150-year jubilee, even if I won't be able to join you in person. Over the next few minutes, I'm going to be walking you through my career journey and some of the lessons that I've learned along the way. Let me start by going back to my time in high school. I think I realized pretty early on that I had a really big interest in maths and science. So very clearly I was a nerd. The thing I enjoyed most about these subjects was that it was all about problem solving. The challenges were always different, and you needed to understand and apply versus memorize. So when it came time to think about what I wanted to study, I knew I wanted to build it on these subjects. I therefore decided to do mechatronics at UCT. Fast forward 4 years, and I began my career working as a control engineer at Sasol. Again, I realized pretty early on that this wasn't something I really wanted to do in the long term. In particular, while I was doing a lot of problem solving, I realized that I wanted to be closer to customers and really understand the business impact of what it is I was doing. I therefore decided to make the switch from engineering into management consulting, and I joined the Boston Consulting Group. So I will say that for the longest time, I had no idea what a management consultant did. And I'm going to assume that many of you are on exactly the same boat. So let me give you a very quick overview of what it is and what I was doing. Management consultants are basically problem solvers that businesses hire for one-off projects where they can't do something on their own. To give you one quick example of one of the projects that I did, I worked with a South African retailer to help them build a new type of supermarket to best serve the needs of the lowest income groups in the country. So these were people that were living off government grants. We helped them curate their range and optimize their stores such that they were able to offer the lowest possible prices to customers while still making a profit. I worked in consulting for 4 years, and while it was super fast paced and honestly a little bit stressful at times, overall I found it to be an incredible experience and super rewarding for my career, as it allowed me to try out a range of industries from retail all the way to airlines, as well as live in all parts of the world. So working and living in Africa, Americas, and Europe. However, after 4 years in consulting, I decided that I wanted to satisfy my inner nerd and move into the world of tech. As an engineer, no company filled me with more awe than Google. So once the opportunity came to work in the strategy and operations team for EMEA, I couldn't turn that down. In my current role, I helped Google solve strategic problems in the EMEA region. So as an example, when COVID hit, helping them think about how they wanted to restructure their business and like change their offerings, that's something that we help them do. I'm quite fortunate that in this role, I've been able to marry two of my big passions, working in tech and problem solving. Taking a step back, let me go through some of the lessons that I've learned along the way. I think the biggest lesson that I've learned is this whole idea of a non-linear career. The premise is this: you can't predict the future. No one knows what the future or the next 10 years is going to look like, or what the next big product or thing is going to be. And because you can't predict the future, you also can't predict some of the amazing opportunities that lay in store for you. And that's completely fine. Your job in life is just to be best prepared to take advantage of some of these opportunities as and when they arise. I believe there's a couple of critical pieces that you need to put in place in order to do that. Firstly, you need to have the willingness to really reflect on what it is that you love, what it is that you don't love, and then really have the courage to act on those reflections. I believe this is something that literally anyone can do, regardless of your background or what you study. The second piece that's important, though, is having the flexibility and skill sets to actually allow you to take advantage of some of these opportunities. And I think that's much harder to do because your skill sets might not align with where the biggest opportunities lie. And that's why I love the idea of building your career on a foundation of science and engineering. There's literally no other foundation that gives you the flexibility in terms of your range of career paths that you have in science and engineering. For example, you can become a hardcore research person, or you can become a technical product designer, or you could even go into entrepreneurship and into business in general. Science and engineering really does unlock all of these different career paths. Anyways, I'm sure that you're all super tired of watching this pre-recorded message, so I'm going to end my message here. I'm really sorry that I can't join you in person, but I really wish you all the best in your career endeavors. Palma Vatuti.
We thank Mr. Yukasparan for that message, and we hope that it will inspire some of our boys in the audience, especially those that are technologically inclined. It's amazing to see the flexibility of a degree in science and engineering. So now we're going to move on to our next panelist, which is Dr. Bruce Bartlett. Dr. Bruce, I'll just do a quick introduction. Dr. Bruce Bartlett matriculated at Selborne College in 1996. He then completed his BSc, which he majored in physics, maths, computer science, and then he did his honors in physics at NMU. I believe that time it was UPE, if I'm not mistaken. After completing an MSc in theoretical physics at Stellenbosch University, he completed an MSc at Utrecht University in Holland. He made the change to pure maths, completing his PhD at Sheffield University in the UK. And then he started his career at Stellenbosch University, where he is currently a senior lecturer specializing in topology and mathematical physics. Dr. Bartlett.
Thank you very much, Cornelia, for the intro. Yeah, I'm so happy to be here and speaking to the boys on this, given this opportunity of 150-year celebrations. I don't know if there's anyone out there who will take something from my story, but maybe there will be one or two boys, so let's see. So I was class of 96, as Cornelia says. My high school started actually in Mthatha High School. Back, that's where I started my high school, standard 5 to standard 7, and then I went to Selborne from standard 8 to standard 10, so that's grade 10 to grade 12. I had Max Norman as my maths teacher all the way through. So I think he retired this year, or I'm not sure, but I think most of the boys do know Max. I think he's still going strong. I'm not sure. Is that right, Cornelia? Yeah. So I enjoyed having Max as my teacher for maths. I think he gave me a really solid foundation. So I want to thank Max for the years that he put into the math teaching at Stellenbosch, and I mean, what am I saying, at Selborne, getting my S's mixed up. But also, he also put in a lot of effort into the maths in the Eastern Cape in general, and even on a national level. So I want to thank him for that once again. Yeah, so after Selborne, so I wasn't really ever a genius at maths, by the way. I didn't get the prize for maths in my year. I think I came second. I did okay in the Olympiads, but not brilliantly. I would get to sort of the second round and then I would bomb out. And when I started university, so at the point at which some of the grade 12s are now, I wasn't sure what I wanted to do. My mother tried to persuade me to do accounting because that's what she does. And she wanted me to go to university at the closest university, which was then Port Elizabeth. So that's why I was at the old University of Port Elizabeth. Now it's called NMU. So I went there and I actually started engineering. And then I found out that I was pretty bad at the engineering drawing. And so I switched to a BSc and ended up changing my BSc. I decided, I want to do computer science. So I added in computer science and I dropped some other subjects. And by the end of my BSc, I had done a BSc in maths, physics, and computer science. And maths was kind of the bottom of the list. Actually, computer science and physics were at the top. And then it's the little things in life that sort of often change you. And I just got a little letter at the end of my third year from the physics department at UPE, the current NMU, saying, well done, you came out top in your little group of third year physics, and here's a small little bursary to start you at honors. And I was so proud of that. That swung me over, and I decided, okay, I want to do physics honors. So yeah, little things like that can really swing a career. I then started with my physics honors and I enjoyed that. Ended up going to Stellenbosch for a master's in theoretical physics. So I already started moving more in the theoretical direction. At that point, I decided, I'd like to go even more into the theoretical physics side of things. So I went to Holland and I did another master's in theoretical physics. At that point, I realized, I want to go even more theoretical. So that's when I changed to pure maths, and I ended up doing a PhD in pure maths at Sheffield in the UK. Came back, started teaching at Stellenbosch. Along the way, I've had a 3-year research fellowship at Oxford as well, which was another story. But anyway, that's my academic career up to now. So what do? I'm a senior lecturer at Stellenbosch. I do research in maths. I've got students and I teach. So I've got postgraduate students and I teach big classes, calculus and algebra and things like that. If you want to get a taste of my research, what I do all day, I play around with diagrams like this. And these sort of rules for manipulating these diagrams, and you can move them around. If you're wondering what it's all got to do with, it's got to do with the shape of 3-dimensional space, and that also has some applications to building quantum computers. But in the end, I'm a dreamer, so I like to sit down and dream of mathematical things. And in maths, there's 2 kinds of mathematicians. There's the ones that can work out little problems, like the ones in the Olympiads. And I wasn't bad at that, but I wasn't brilliant. But then there's also the dreamers who try and think structurally and how various fields fit together and the analogy between something and something else. And that's where I fit in, and that's where I'm pretty good at that kind of thing. Anyhow, so I think I'll stop there. I don't want to carry on for too long.
Thank you, Dr. Bartlett. And I think, that's a testament to say to the boys that Maths is actually not that bad, and it's quite exciting. And it's nice to hear about the amazing research that you are doing. So hopefully that would be something that the boys would also want to pursue in the future. And now we're going to move on to our third panelist, which is Professor Richard Gordon. Interestingly, Professor Gordon has actually addressed us at our prize giving. He's Professor Gordon matriculated from Selborne College in 1990. He completed his PhD at UCT in 1999. And then he did a postdoc in chemistry from the University of Cambridge in the UK. He's currently the Professor of Health Sciences at Northwest University. He also serves as the Executive Director of Grants, Innovation, Product Development, a unit at the South African Medical Research Council, where he oversees grant funding, international partnerships, innovation, and in health. Professor Gordon.
Thank you very much. And can you see my slide that I've put up?
Yes, we can see it.
Thank you, everyone. It's a great pleasure and an honor to be here. I really count myself very fortunate to have gone to a school like Selborne College that really has been the foundation to where I am today, and I believe that very strongly. I've been asked to talk a little bit about my journey, as you've heard in the first two speakers, and kind of what I'm doing today, and I'm going to tell it in pictorial format because I like to see pictures. So this is the picture of the first team cricket team in 1989, and you'll notice on the second row and the second from the left there might be a familiar face of your headmaster, who I had the pleasure of playing cricket with for a couple of seasons in my last couple of years at Selborne. So Mr. Dewar and you'll see quite a few familiar faces in that picture of quite a few national players who came out of that team. So I was a cricketer. I was not really a great rugby player, and I was not a great academic like the previous speaker. I was pretty much, I'd probably be in the top 20. And my story is that I didn't even do science at school. I dropped science in standard 8 in grade 10 because it wasn't something I actually enjoyed, and I actually wasn't very good at it. So I didn't do science. Can you see the next picture? I just want to check that my slides are moving.
You can see it, Prof.
So I thought I'd put a couple of memorabilia pictures in. My very first teacher at Selborne was Pete Kutsia, and he had only been at the school about a year, and I had the pleasure of him being my teacher for 3 of the 5 years I was at school. I'm not quite sure how that worked, but he was an inspiration and a very nice teacher to get into. Come into Selborne, because I never went to Selborne Junior School. I went to other school in East London, and I came in and didn't really know anyone. And having Mr. Kutsia as my teacher, I count myself very lucky. Cricket was my game, and you'll see a few familiar faces there. I'm the guy in the middle. Cricket was my game. Mr. Norman is sitting to my left, and I think some of you all know Sean Faree and Paul Safi. I think you're still actively involved in the school, and there are so many people in this photograph who are all around the world doing some incredible things. And I just wanted to show you from an under kind of 15 cricket team where people are around the world, that this is a pretty special place, and you guys must count yourself very fortunate for being here. My last picture that I wanted to put up was, I actually got this going through my old school magazines, and it looks like a really old picture. This is 1989, Changing of the Guard. The man holding the flag in the middle is Mark Andrews, the Springbok rugby player. The man to the right-hand side of the picture is known today as Frank Rotenbach, who's the famous actor from Selborne College who went to LA, was in quite a few big movies. I'm the guy on the far left-hand side with the back to everyone, looking at all the others, trying to see if they can stand up and not faint during the ceremony of the key. So I thought that'd be fun, just to put a little bit of context, that I was a very proud Selborne graduate. I loved my school, and I was not any good at science. And I think the key thing to come through this message, and my key message, is don't try and think when you're 18 and 17 years old that you've planned your whole career in front of you. both of the previous speakers will tell you how their careers evolved, and they're still in their 30s, early 40s, and they've still got 20 years to go in their career. So I went to UCT not knowing what I wanted to do. I thought I wanted to do medicine, but I didn't do science. So I went and did a sort of a gap year where I did A-level chemistry with no background in chemistry, and that only got me through the back door into UCT. So I did a very general undergraduate degree in a BSc, and then I majored in biochemistry, microbiology, and chemistry in my BSc. And it was during the chemistry that I realized I was actually quite good at one of the elements of chemistry, and that was organic chemistry. Three-dimensional structures, putting these into place, and designing and making molecules and drug molecules. So that's really what I did for my PhD, designing molecules from using 3D imaging on a 2D piece of paper. So it was not something I planned. It was not something I knew when I was at school. It was only through my kind of experiential learning, and as both of the previous speakers, you kind of work out what you like and what you don't like. And it's more important to work out what you don't like, and to follow your passion. And I'm a firm believer that you do not know when you're 18 years old, unless you have a real calling, where you will end up. And so don't plan your life to be something when you're 18. You still got a long way to go before you can get there. Do something general, and the doors will open as you go. So my PhD at UCT got me into Cambridge. I spent 2 very, very enjoyable years in Cambridge, where I was using the same skills that I had done, but using a different reaction medium. I was using supercritical carbon dioxide. If you cool carbon dioxide and you put it into pressure, it actually turns somewhere between a liquid and a gas, and that is your reaction medium. And that's what I did. There are quite a few patents out of there. There's a whole new industry that's been kind of created by how you use these supercritical fluids as green fluids for chemistry reactions. But my time at Cambridge taught me that I was never going to be an academic. I wasn't bad at the science. I didn't eat, sleep, and drink the science. But what I was good at was using science and interpreting it for other people to synergize. So I went and worked in the private sector at a small company called Biofocus just outside Cambridge, on one of the science parks there, where I literally moved from the laboratory after working in drug discovery for several years to the area of strategic alliances, and the ability to talk science and bridge the gap between people who were designing a molecule, the people who were doing a biological assay, and interpreting the data of how you would use that to design a drug. So that's what I did for most of 10 years, where I then spent a very large percentage of my life on aeroplanes, didn't go into a lab for about 10 years. We're going around the world forging research collaborations with pharmaceutical companies and biotech industry in the UK. So that's what I did, and I basically used my science as a way to pivot into building business relationships. I then came back to South Africa in end of 2012. I had a bit of kind of a gap year at TIA, and then I joined the Medical Research Council, where I set up a new grant funding innovation unit, and probably the thing I'm most proud of in what I have done. South Africa punches well above its weight internationally in what it does, and my 2 messages I have for you in this talk is: don't try and get your career panned out when you're 18 years old. Time will evolve. And the second one is, we are well trained and well schooled in coming from South Africa, and don't ever doubt yourself for 1 second. If you go overseas and decide to study overseas and then come back, a lot of people say that they're not going to be able to fit in, they're not good enough because they come from Africa. That has never been my experience from people that I know and myself that went over. You really need to back yourself. And I think the previous 2 speakers are really great testament to that as well, when they went and backed themselves. And I'm sure they were nervous when they left. And then I've got a couple of slides on the kinds of things that I had been involved with in the last few years. And I've kind of picked the ones that you will know, just so it becomes more relevant in the world that we're kind of living in. So the first one is, I was very fortunate to be involved in the setting up of the first human genomic sequencing laboratory in Africa, where on the left-hand side is the Beijing Genomics Institute, a Chinese company my boss, Glenn de Grey, president of the MRC, where in 2017 to 2018, we built the first human genomic sequencing platform on the continent. And this was essentially basically about 25 years ago. It took about 10 years to sequence the first human genome. You can run 8 human genomes in 48 hours and do that sequencing and get that data. And then the fun for the mathematicians then gets to play. So the third message I want to point out to you is the way the world of science has evolved. And I think the first speaker said it beautifully. You actually don't know how it is going to evolve. Because where we are today, it is really at the interface of genetics, computers, biochemistry. This didn't exist when I was at school. And this is really the era of big data and genomics and how things happen and how they happen. So if you like mathematics, if you like computers, if you like biochemistry, this is the perfect match. And you don't need to be strong in all of them, you just need to be strong in one of them. So that's the one program I'm very proud to have been involved in the last kind of 3 years. And this lab was open in 2019, and it's probably sequenced up to 1,000 human genomes since then. The second project that I've been involved in, you may not know, but I'm sure you've seen it in the news. It was a program called the Genomic Surveillance Network of South Africa. And this was really a grant that came from our unit to the MRC, where it was trying to string together a number of research groups across South Africa to do surveillance for COVID and what was happening with COVID. So these were teams of people, biochemists working in the lab, big data crunchers, bioinformaticians, artificial intelligence algorithms, a whole multidisciplinary team. And the little story on the right-hand side was an outbreak at the University of Pretoria from students who were having get-togethers at the end of last year. Well, I'm sure it wouldn't surprise you is that in the week 44 of last year, that was how the positivity rate looked in South Africa on the left-hand side. And as 2 weeks later, you can see how the picture has evolved, where you have right high level of contamination and spread. Well, that was the start of Omicron. And this was the project that discovered Omicron. All funded locally, all the research done locally. And this is what brought Omicron to the world. Unfortunately. And the same group also discovered the beta variant in South Africa. The same research network, taking samples from around the country, putting them into machines, genomic sequencing machines, and coming out with the data. So that's how science is used in real time to drive the pandemics. So Omicron, this is all funded locally, it was all developed locally, and we kind of have been leading the world in this area for a long time now. And the last 2 examples that I'll just talk about is my world has kind of moved to vaccines in the last year. And this was the cover page of a grant that we submitted to the World Health Organization in April last year to talk about the developing a vaccine hub in South Africa. A long story short, we were very successful. We were happy to be the successful applicants. And this was announced by, and luckily, the president of South Africa and a number of African presidents and the DG from the World Health Organization as the mRNA vaccine hub for the world. And I'm very excited to be part of a program such as this. And my last slide, very quick one. Some of you would have seen the news about a South African, a Chinese South African billionaire living in LA. His name is Patrick Soonchung. Many of you may or may not know, but Patrick actually grew up in Port Elizabeth. He went to school in Port Elizabeth. And he married a girl from East London, Michelle. And they have set up this foundation called the Chan Soonchung Family Foundation, where based on Patrick's history and his love for South Africa, he's now giving back. And this is the last thing that I'm currently involved in helping the Chan Soonchung Family Foundation, setting up research scholarships for researchers from underprivileged backgrounds. So I'm going to stop there, but just I think I made the points about planning your career. But these are the kinds, that's my story of how I got to where I am. It wasn't a linear path, it was all over the place, and I'm still not really sure where I'm ending up. I'm going to stop there. Thank you.
Thank you, Prof. Gordon. And thank you for that message. And it's quite exciting to see the amazing things that you've been involved in. And it's interesting to see that science can be an intersection of different careers, and it can branch into exciting things and provide exciting opportunities. Thank you for that. And then so we're going to move on to our fourth panelist, which is Professor Helmut Winkelmann. He matriculated in Selborne College in 1979. He holds numerous degrees from UCT, including a PhD in astronomy. He completed an equivalent of an MSc in physics from the University of Heidelberg in Germany. Professor Winkler has published nearly 50 papers in scientific journals. He has done a lot of research in atmospheric physics, energy, and more specifically in solar irradiation. He's currently the professor of physics at the University of Johannesburg. Professor Winkler. Prof, we can't hear you.
Yeah. Okay. Yeah. Good evening again. Yeah. So as was mentioned, I was at Selborne until 1979, and we already heard about Max Norman earlier. He, I think, started in 1978. So I was one of the very first people that he would have encountered when he came to Selborne. And I think Mr. Norman had a lot of foresight because he decided to introduce an advanced mathematics course. It wasn't compulsory, it didn't count for anything, but he introduced it anyway and invited a couple of the people that were doing well at senior level to join that. So I was one of those people that did that. Also, I was always very good at maths. Fair in other subjects, but maths was always my strong point. And I think I have to give a lot of credit to somebody else who, I'm not sure to what extent people know him, but Peter Gordon. He later became a deputy principal at Selborne. Mr. Gordon had just one idea about how to teach maths, that you must just do exercise, exercise, and exercise again. And I found that this really worked. You don't have to be, have some of these special techniques and that in order to understand science. Ultimately, you just need to practice, 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 and eventually the penny will drop. And I found that that's what our maths classes were like. We would come into class, he would put some problems on the board, we would do them, we would sit there for the entire period. And after that, our whole class was actually extraordinarily good at mathematics. Anyways, so I've sort of kept that with me. And whenever I teach now, and I teach a lot of students, that's also my philosophy as far as teaching is just do it, and do it again. And eventually you will become good at it. It doesn't matter whether you're a genius or not. Anyway, so as was mentioned, I went to UCT after that. And initially I wanted to do specialize in mathematics. In my second year, even though I was always very good in my second year, I started not understanding a couple of things perfectly. And that's when I started getting a little bit worried. And well, I then decided, okay, well, I'd been doing physics as my other major, and I did an astronomy course, and I decided, yeah, well, I quite like that. So I ended up majoring in physics and applied maths, and I did my honors in physics. After that, I wanted to go overseas. So I went to Germany for 2 years, decided to come back and did my PhD in astronomy. And that meant that I needed to spend a lot of time in this place. Oops, let's get it on. This is a picture of the South African Astronomical Observatory. It's in Sutherland. It's about 4 hours drive from Cape Town. So in total, I spent during my PhD, in total, I spent about 6 months up there. And it all sounds all very nice and romantic. I mean, this is usually what one thinks of when one hears astronomy. It's not quite like that all the time. It's an incredibly cold place. In winter, it's horrible being out there at night, especially with the winds howling and so on. And also, it does mean you need to stay up the whole night, and that I found a bit difficult. So anyway, having finished my PhD, I decided, no, I don't think I can do this for the rest of my life, even though ultimately I'm still doing a lot of it to this day. I decided to branch into more conventional physics. There was an opportunity to start teaching at what was then the new university set up in Soweto itself. It was called Vista University. And I decided, yes, let me do that. This sounds really exciting. And I went there, and it was a time of turmoil. It was the 1990s when the country was going through a huge transition. We had all sorts of experience. I don't think I have time to go into all of that. But anyway, I think I learned quite a lot, be it about politics, be it about other people, be it about other cultures, what have you. While I was at Soweto, I decided, well, how can I adapt what I had learned in astrophysics to something else which was maybe going to prove useful at that campus. And at that stage, there was a huge power station right across the road from us. There was just soot and dust, and also in the mornings, because people were burning a lot of coal, it just meant that you just every morning you would just drive into the smog. So I decided, let me investigate air pollution. And I found that there was actually a link between what I was doing in astronomy and air pollution, in the sense that in astronomy, you have the light from stars going through the atmosphere, and then you measure it. So you have to know what is happening to it while it's going through the atmosphere. You can also turn the argument around. You can actually use the light from stars to measure what's happening in the atmosphere. And that's exactly what I then ended up doing. I progressed beyond just looking at air pollution as such, but looking at the transport of aerosols. Now that's related to global warming questions. And eventually then I drifted into energy science. Especially given that now that solar energy is becoming more and more important, we need to know exactly how much sunlight we're actually reaching on the ground. And that's affected not only where you point your panel on that, but also how much atmosphere the sunlight needs to go through. So as a result, I've kind of specialized in that too, and doing calculations exactly how much light can you expect at any particular location on the ground. And I've got a couple of students that have been working on that. Then at some stage I decided, well, it was almost by chance, I got worked up about something with nuclear energy, and I decided to write an article about that. And since then I've written quite a few articles about whether this country should get nuclear energy or not. Also I started looking at energy questions and so on. Anyway, the long and short of it is that I do, as a result, end up quite often, let's see, yeah, sorry, that's supposed to be me on television. So I end up being called quite often whenever there's load shedding. It's one thing that happens, other people don't get electricity. I normally get a phone call from some news outlet asking me, well, how long is this load shedding going to go on for, and what's the country doing about that? So that's one of the roles of a scientist, actually, that we need to, in a sense, not only figure out the bigger picture and that, but also try and explain that to the broader public. Just to give you an idea about what the life of a scientist is like, it'd be nice if we could spend our entire days in the laboratories and so on and picking up data if that's what we really want. In reality, it doesn't work out like that at all. There was already a mention about how we need to apply for funding and so on. So it takes a lot of time. Teaching sounds nice, but most of the time we actually spend on things like marking or just preparing exam papers and so on. Rather boring work in that, but it's part of our job as well. But all the same, I think the reason why we are in this field is there's a couple of pluses I see. The one thing is that we are not in a formal structure as such. So we don't have a boss who tells us do this now and come back to us when you're finished with that. We have a lot of independence regarding what we can do. If I get an idea and I decide I want to investigate that, usually I can. Only thing people want at the end of the year, they want me to have written a couple of papers and that. But what kind of papers they are and so on, that's ultimately up to me. Also, we work on flexi time. I don't have to be there at 8 in the morning or so. Sometimes I decide I don't come to work at all. But on the other hand, sometimes you'll find me working on a Friday night or on a Sunday afternoon and that. But I like this aspect of flexi time. Also, we don't need to dress in any particular way. So that's all very nice. We do quite often, although it depends on what kind of position you have, but one of the pluses of being a scientist, you do get around a lot and you get to relatively nice places. Conferences is one of our great favorites, and before COVID, we actually used to go there, and people organizing conference normally do that in some of the nicer locations around the world. Also, we meet a lot of people internationally. So I, for example, spent 6 months in Japan. I spent time in the US, in Belgium, in Italy, in Germany, quite a few places around the world, in China recently. So we do get to that as a plus. The minus, of course, is that we don't end up being millionaires in that. We don't earn as much as engineers. Let's be straightforward about that. If you are into making money, maybe science is not always the way to go. Although I know quite a few people that started off in science and then went back into some more lucrative professions, such as investment in that, especially in physics and that. Companies have come to the conclusion that people that have been through a science degree are better lateral thinkers. So as a result, that's a desirable quality. You want people who are able to adapt. You want people who are able to think out of the box. And so it is still possible, once you are in a science career, to go into something else. This is not often possible elsewhere. The final thing I just want to mention is that don't think that because you want to go into science or into any other branch, that you must just forget about the other subjects. I cannot think of anything I learned at school, doesn't matter what subject it was, that I haven't at some point or other in my life needed, right? Whether it's accountancy or so, I have learned something. It's very basic stuff, but I'm glad I learned that. Yeah. Writing and that, I never was thought of myself as a particularly good writer. Now I write more than probably most other people, right? Whether it's memos or whether it's articles and that. So I wish I had tried a lot harder at school at some of the other subjects. They're ultimately just as important as the subject that you enjoy much. Okay, so thanks for that. I'll finish with this now.
Thank you, Professor Winkler. That was very nice to hear your experiences in science, and specifically someone who's involved with a lot of research. And it's amazing how everyday experiences can actually inspire scientific inquiry. Also, just to add, Professor Winkler has also addressed Selborne College at the prize giving. So we do expect Dr. Bruce Butler as our next guest at prize giving. No pressure. So our last panelist is Professor John O'Dell. He matriculated at Selborne College in 1967 and completed his degree at UCT in 1973. Professor O'Dell has served as the head of the cardiothoracic surgery at Groote Hospital until he took up a post at the Mayo Clinic at Jacksonville, Florida in the USA. When he retired in 2013, he was the head of the cardiothoracic surgery at Mayo Clinic. He's currently the emeritus professor at Mayo Clinic. Professor O'Dell, the floor is yours. So we can't hear you, Prof. Please turn on your mic. We still can't hear you, Prof. Look for the red arrow at the top. It should be the green button just below that.
Unmute myself. Okay, can you hear me now?
Yes, we can hear you. We can hear you.
Oh, great. I'm honored to be with this illustrious group. Obviously, I'm here because I've been recognized by what I've achieved. And when I was asked to join it, I wasn't given much direction of what was expected. But it gave me some time to reflect on my career, and I'll share this with you. When I matriculated in 1967, I got my matric results probably on the day that the first heart transplant was performed by Chris Barnard. I was enthralled by this. I was about to start a career in medicine, and I read voraciously everything about the procedure. Never in my wildest dreams did I expect to take his place as head of the department. I worked with the same anaesthetist who gave the anesthetic at the first heart transplant, the same perfusionist who was there, and my scrub nurse was the scrub nurse at that first heart transplant. I spent 6 years at medical school in Cape Town, then went to Durban. I had to repay a bursary provided by the Natal Provincial Administration. I also had received a loan from Selborne College, and I repaid that within a year of working. I'm not sure if this facility still exists today. I wasn't sure what I was going to do. I was, I think, planning to be a general practitioner, and I rotated through all the specialities of medicine: obstetrics and gynecology, medicine, general surgery, pediatrics. But during my general surgery rotation, I rotated to Wentworth Hospital, which was where they did cardiothoracic surgery. And after my first day, I realized what I wanted to become. I enjoyed everything, but in cardiothoracic surgery, I could be an intensivist, a cardiologist, a pulmonologist, and I could operate on the neck, the chest, the abdomen, and even in the legs. I enjoyed every day of my career. I did my general surgical training at King Edward. It was very busy. Sometimes we would have over 100 admissions in 24 hours, and we regularly operated all through the night. I spent a year in Scotland and then returned to Durban as a consultant surgeon. I then got approached by Bruno Reichardt, who took over from Chris, asking whether I would join him in Cape Town. It was soon obvious to me that Bruno was likely to return to Germany, and I accepted the position. If I reflect on what I did, I think it was associated with a lot of luck. I was in the right place at the right time, and I took opportunities when they were offered. Having said that, I created these opportunities. I read widely about my speciality, and I realized that to advance in an academic career, one had to write and do research. And I have edited 4 books, published widely, and one of my articles has been cited over 1,000 times. I had excellent mentors. At Selborne, I had Alan Weber, who taught me mathematics. Every one of the other participants mentioned they liked mathematics. I also had Jack Benyon as my English teacher. He pulled me aside one day and asked me what I intended to do, and I said, I intend to go to university. He said, you'll never succeed. You're messing around too much. When I became professor, I wrote him a letter telling him what I'd achieved. I never got a reply. So I've enjoyed every minute of what I've done. I got incredible pleasure out of making a blue baby pink, of moving a diseased heart and replacing it with a heart that functioned much better. To relieve somebody of shortness of breath by replacing or repairing a heart valve or a heart defect gave me a lot of pleasure. When I had my 50th Selborne reunion in 2017, a father approached me and told me that a son that I'd operated on him 25 years before was doing well. That gave me enormous pleasure. Some recommendations to you all. Don't assume to be an expert. If you assume to be one, you will annoy people. Frank Lloyd Wright, the famous architect, says, an expert is a man who has stopped thinking because he knows. I try to communicate well with my patients and with my staff, and I've been scrupulously honest throughout my career. If things go wrong, you must admit it and try and recover from the situation. One thing, if you're honest, you don't have to remember what you said before. I never tried to micromanage. I let the members of my staff manage what they'd been assigned to do. I chose very good staff. These are the most important things in any organization, is to have good staff. I worked hard, but I also relaxed, and I always took my vacation. Nobody thanks you for not taking a vacation. So enjoy your passions and your life outside your career. And lastly, I used the mirror test. And this is based on a short poem written by one of my best friends, a cardiologist who unfortunately died prematurely of pancreatic cancer. He used to state it often towards the end of his life. It's entitled Mirror. Each day I wake up to be as good as I can be. So when I look in the mirror, I like what I see. The choices of the day are many, the temptations will surely grow, and the judge that's in the mirror is the toughest one I know. On looking back on roads I've walked and places that I've been, I hope that those with whom I've walked will want me back again. So when the day is over and all the races run, I want to look in the mirror and know that I have won. For those of you contemplating a career in medicine, the most difficult part is getting into medical school. When I got into medical school, there were about 1,700 people applied and only about 150 got in. So this is where attention to your education pays off. Don't rush into a speciality. There are so many different subspecialties, you will always find a niche. I've seen so many people rushing into surgery who were not suited for this career. They were like a round peg in a square hole. I wish you success in your choice and your career. Thank you.
Thank you, Prof. I mean, thank you for sharing with us such a rich experience, and the lessons in that are quite profound. And I'm hoping that the boys, will take that to heart, especially for the boys that are actually hoping to get into medicine. So we'll now move on to our Q&A session. So I see we've about 8 minutes. I was waiting for persons with the questions. While we're waiting, I just have a couple of questions of my own to Professor Dr. Bartlett and also maybe to Prof. Winkler. About maths. You see, students don't, especially in high school, they don't really want to, they don't really see anything in maths beyond high school. They don't really want to pursue degrees in maths. Can you speak on the opportunities that are afforded by maths degrees or degrees in pure maths after school?
Yeah, so I'm just Dr. Bartlett, not professor yet. The careers in maths, so it is, you can go into finance, is one thing that people like to do. You can often go into programming and coding at a sort of more analytical level. So the guys are doing the algorithms more than the guys who are just typing. You can nowadays, data science and artificial intelligence is a big thing. And always there's actuarial as well. So the insurance industry. And then last but not least, there's academia. That's my take on it.
Yeah, I'd just like to say, maths to me is the most important school subject you can possibly do. It's the one subject that if you aren't very good at it at school level, you're probably not going to catch up on it afterwards. It's really critical. I think everything you do in mathematics, and that is something that needs to be absorbed slowly. One can learn history after school. Richard just told us how he learned science after school, but I don't think the same is true for mathematics. And yes, I think the point's been made several times here that what you're going to choose to do initially at university is not necessarily where you are going to end up. I think every one of our speakers had that kind of experience. So, but starting off in maths and having a good grounding in that really opens all the doors. I think after that you can go for almost anything you want.
I think English is also very good.
Prof. Odell, can you please respond to that? So continue.
I'd said that English was also very important. You're able to communicate better if you know English. You can write your papers if you have an academic career. So I think English is also very important.
But there's a question for Professor Richard Gordon. Prof, the question here is, do you ever regret not doing medicine?
No, not at all. I suppose I've got a surrogate medic. I'm married to one, and I think seeing what they do. No, I have no regrets. And I suppose building on that from what other people have been saying beforehand, everybody who's spoken here has done exceptionally well in their careers and is doing exceptionally well. None of them had a linear path from the beginning. They all had to find their niche. So and building on that in terms of the sciences and what Bruce is talking about and what Harpend is talking about, I think that the thing that limits a lot of the boys at school when they're looking about what they want to do in university is actually the knowledge of what's possible. Everyone thinks if you do maths, you're going to be an accountant, you're going to be doing computers. Well, computers can be used in physics, it can be used in genetics, it can be used in just about everything these days. And it's not like when we were at school, maths, you tend to be in this trajectory. It's not like that anymore. And people are only really limited by their own imagination and understanding of what is available. So I'm not going to disagree with what anyone said beforehand. I don't regret not doing maths at all. It was the right thing for me. And like Prof. Odell said, I'm going to be a bit blunt about it. There are lots of people who did surgery who probably shouldn't. When I was at first year at varsity, there were lots of medics studying medicine who probably shouldn't have been there either. And I think that's based on my experience.
Thank you, Prof. And to the members of the audience or attendees, please, if you have any questions, can you please ask your questions on the chat so that the members of the panel can respond to. Here's another question for Prof. Winkler. The question is, you've traveled the world. Did you ever consider moving overseas?
I suppose we never really quite know where we're going to end up. The reason I am where I'm now is, I guess that's just where I was offered a job. A lot of people do end up overseas, though. In a sense, it's a bit sad seeing people leaving the country for other places. But on the other hand, we also get lots of people coming in here. Have I considered it? Yes, I have. Certainly, I wanted to specifically study overseas. But I think once I've been here, it's not been a situation where I've decided, oh, I don't want to stay any longer. I need to get out of here. One can. This country is fairly good at when it comes to sciences. We have got some fairly highly ranked universities. So I think most things are possible to do in this country. Certainly, I know some of the American institutes and that are. If you really want to go for performance science, that might be helpful to you, but it's not that we don't have opportunities here. We do.
Thank you, Prof. And also just to mention, Prof. O'Dell has been awarded the Better of the Palm award from Selborne College for his contribution to medicine. And then there's another question here for Dr. Bartlett. The question is, do you plan to go to the world of business one day?
I've got a sideline in financial maths, but I think it'll remain a sideline.
All right, thank you. Also, just to remind members of the audience again, please, if you have any other questions, can you please post them on the chat? I'm just being told that you're going to go up until 9:40, so 10 more minutes. Just another question here to the members of the panel, so anyone who wants to take the question here. So the question is, I know that the government does publish the list of critical skills generally for all different types of fields. Do you have maybe, let's say, 3 skills that you think are very important in the world of science and that you advise that boys should consider venturing into those fields?
I'll kick it off if I may. I'm not sure I agree with the phrasing of the question. You know, as we said beforehand, mathematics at school is very important to catch up. You can't catch up if university is too late. You've got it, and English is pretty much those key skills. What I find is it's not really the disciplines that you need. What university will teach you, what science will teach you, is to problem solve, and that cuts across all disciplines and addresses many things. I think the ability to problem solve will get you most of the way to some of those questions that you need to develop. A degree does not get you a job. It demonstrates you've got a degree. It gets you an interview. So it's the skills that go around that I think are as important. So you know, that's just my 5 cents worth.
If I can just say something that's often forgotten about, and Prof. O'Dell alluded to it, is human skills, human interaction skills. Ultimately, none of us actually sit in our little rooms with the papers and computers all around us without ever talking to other people. We interact with people very much. We are in some sort of an organization. We need to somehow motivate people and so on. So those aspects, of course, they're useful for any kind of career, but that is certainly something I found is often neglected in our career.
Thank you, Prof. Prof. Gordon, just to follow on from your response there, you did mention something about universities. Can I ask again? You see, students tend to want to go to elite universities, and obviously most of you have been and taught at universities. How much factor does that have in terms of speaking to you as a person who has a degree, going into a job or anything like that? Does that have an impact, or does it purely depends on you as a person and how much work you're willing to put in?
I will give you my my take, and I'm sure that others will have something to pitch in. And I'll give you a very quick example. I was at an interview for McKinsey, a very interesting, you know, probably Boston Consulting Group, our first speaker, where he used to work. And I was doing my PhD, and McKinsey were targeting the people in the life sciences to go and work there because scientists would think of as lateral thinkers. I hadn't thought of McKinsey, I'd never heard of them, I didn't know what they did. And while I was sitting there in the waiting room, there was a pile of paper about a foot high, and the HR director was just thumbing through these, literally 2 seconds per CV. And I asked her, what was she doing? What was she looking through? And she said, this is the Harvard MBA class for this year. And all she was looking for was which people in the Harvard MBA class had a link to Africa. So the answer is you don't know what the person hiring is looking for. A degree could be the swinging factor. It could be, but you know, if you apply for a job with engineering, there'll probably be 200 other engineers who qualify to take that job. So my firm belief is that the university degree, the school you went to, gets you the interview. It might be that if you go to an Ivy League university, you might get more interviews than others, but you know, that's kind of illegal these days to interview people from one university and somebody who got a degree at another university with similar grades. You can't just pick one over the other theoretically. So I believe CVs, degrees get you the interview, and what John and Hartmut were saying, it's the soft skills. Is this a nice guy? Do I trust him? Does he look at me? Does he look at the floor, or she look at me? I'm talking about guys in this case because it's Selborne. So the soft skills are really important. And I really do think that, you know, in this case, Selborne, that's what Selborne gave me. You know, I had a great group of friends. I was treated like an adult. I respected my adult. I tried to dress properly when I went into interviews. It was the soft stuff that the school gave me that I didn't really appreciate at the time. And I think that's a very important message that comes through.
Prof, thank you for that. And then there's another question here. I believe maybe it is for you, Prof. Burton, as maybe Professor Winkler as well. It says here that vaccines and solar power are very topical. How are developments in this field likely to be? And that question is from Mr. Norman.
So could you repeat the question, Cornelia?
The question is, vaccines and solar power are very topical. How are rapid developments in this field, that means vaccines and solar power, are likely to be? So future developments in the two fields of vaccines and solar power.
So I can talk about vaccines. So I mean, I think COVID has been horrendous for the world per se. There have been some incredible stories as well that have come out of it for scientific innovation. And you know, you don't really innovate as well until somebody forces you to innovate. So the vaccines of Pfizer and Moderna and BioNTech, you know, were the first vaccines of mRNA. And, you know, without getting too technical, they're the first of their kind to have been developed. And they were actually developed for cancer. And no one had ever thought that this would work in a pandemic response. So basically, it forced the world to innovate. Now, mRNA or RNA-based vaccines are probably going to be the future because they're so versatile and can be developed so quickly. Now, it's not going to be a binary, this is going to change the world forever. Some vaccines, some diseases, an mRNA-based vaccine is not going to work. But in the vaccine space, it is definitely going to be very different. And I think you're going to see the benefits of this for the area of cancer. Because these the area of precision vaccines for cancer, where somebody goes in with a particular tumor for cancer and you develop a customized gene therapy or vaccine for that individual, that one person. And that's where mRNA is going to really come into its being. So vaccines are going to be unrecognizable in the next decade, that's for sure.
Okay, if I can come in regarding solar panels, I see the world moving in the direction that when you build a house, you're going to build some solar panels to go with it, just like now you build it with toilets and water to go with it. I also see the big power stations and the power lines that cross a country not being as important anymore as they were. I see a situation where we're going to be having electric cars in about 20 years' time, and where instead of going to fill up in the garage, you just simply plug it into into the plug you have at your house. So yes, with the prices of solar panels having come down so drastically over the last decade or so, that trend I think is likely to continue. I wouldn't be surprised though if something completely different comes up to solar power. Solar power at the moment seems to be the best, especially a country here where we have lots of sun. But who knows what the next 10 years will bring? We might be having something completely new.
Thank you, Prof. And there's a question here. I just have 3 more questions. Question for Prof. Dahl, and it's from a student, Bruce Bartlett, and then he asks, if you don't get into medicine straight out of matric, you recommend proceeding with the BSc and just keep applying? And if that is the case, then what BSc do you recommend?
Well, next year will be 50 years since I'm graduated, so things have changed a little bit since then. But for example, myself, the first year medicine was physics, chemistry, botany, and zoology. And I love physics. I nearly decided to continue doing physics. And some of the people in my class sort of diverted to get a BSc and then joined in medicine, and they could do it with just in a year or 2 extra. So they ended up being a medical doctor with 2 degrees, a BSc and an MBCHB. And that's pretty much what they do in the States. They do a pre-med degree and then a 4-year medical school class. So it's not 6 years. In South Africa, it's all combined. I think I'm not unsure of the selection process, but I would think the bias would be towards a scientific BSc degree.
Cornelia, can I comment on that?
Would be fine.
Could I comment on that as well?
Yeah.
Yes, please go ahead.
So I think it was Bruce who asked, Bryce who asked the question. Bryce, when I got to UCT, I sat in a lecture hall with 800 other first-year students. Probably 200 of them were wanting to do medicine and didn't get in. And we were told, and this is 1991, 92. And we were told straight up, if you think this is the back door to getting into medicine, think again. Because if you think of the numbers, probably if you're looking at UCT or WITS or whatever, they probably take 200 in per year, 250, probably get a couple of thousand applications for it. And then maybe at the end of year 1, there's a place that opens up. So if you go trying to go in the second year, you're then competing with another 20,000 applicants to get into first year medicine. And you might be the 1 or 2 people who are lucky to do it. It's not a route I would recommend going because it's very, very unlikely to actually pan out. I think I know 1 person in 10 years who's done that. So it's not a good way to do it.
Yeah, I've worked with a lot of people who've been to lots of different medical schools, and the head at WITS, when I was head in Cape Town, he'd gone to medical school in Lorenzo Marx, and he was a fantastic surgeon. And I worked with transplant pulmonologists here at Mayo. There was one from Guatemala, one from Dominican Republic, one from Peru, and one was from South Africa. And they were the best clinicians you could think of. So I think what it's telling you is that it's what you make of it rather than the institution.
Thank you, Prof. And we just have one last question. And this question applies to all of you. So we'll start with Dr. Bartlett. The question is from a student, Adam Kratzman. He says, what has been the most challenging part of your scientific or mathematical research, including your PhDs and other degrees?
some problems I haven't. The most challenging part of my research is some problems I'm still thinking about that I've been thinking about for 10 years and I still haven't solved. So yeah, I guess the most challenging part is just choosing a problem that you can actually solve. Yeah.
Well, a lot of research, you come up with a hypothesis, but it's just, and you may be disappointed if it doesn't turn out to be how you expected it to be, but it's still valid because if it didn't prove the hypothesis, it's you've at least proven something. I think it's called the null hypothesis, but the experts can talk about it.
Prof. Gordon, you want to respond?
The hardest thing.
So I suppose if you're thinking of practical examples, I would say halfway through my PhD, I was struggling to try and get a reaction to work, following a literature method, and it didn't work. And I got so infuriated and frustrated, I actually emailed the professor in the US that his reaction didn't work. And he replied within 24 hours with a full protocol that was not in the actual publication. So I probably spent 4 weeks trying to get that one reaction to work. And I learned things the hard way. So the lesson is, if you don't know, ask. And you know, at what am I doing now? I think it's you know, prepare for the unexpected. You know, I'm dealing in a world where it's as much science as it is politics at the moment, and sometimes decisions aren't based on science. They're based on factors that you're just not aware of. So that's probably the most frustrating thing that I would have today.
Professor
Quickly, I think the hardest thing I've had to do. Yeah, I think the hardest thing I've had to do is to try and understand what happens in and around a black hole, and I still don't understand it.
All right. So unfortunately, we've reached the end of our session, but I'll just read out the remaining questions, and these questions will be answered by email. So Taran Sen asks, for someone who is not sure what sector of their field to go into, in physics or maths, is there any broader degree or path that keeps your options open for later on? That's the first question. And then the second question was, let me just find it here. And then the second question was, this was specifically directed to Professor Hotel. The question was, can you perhaps you know, share with the boys a few tips on how to manage through their 6 years of a medical degree while balancing a life, hobbies, as well as sport?
Well, how do you balance sport at university, or is that the question?
Yes, that's the question. So how do you manage the 6 years of medicine while balancing the hobbies as well as sport, if you are doing sport?
I don't really know how to answer that.
It's called life.
Sorry?
I was about to say, it's called life. How do you balance life? I think that's the skill they have to learn.
Yeah, my attitude has been work hard, play hard. You know, when I took my vacations, I traveled. I climbed Kilimanjaro. I went on safaris. I do photography. So my attitude's been work hard, play hard, and that's what I would recommend. Is and try and balance that as much as you can. If you try and just work and not do anything outside, I don't think it's worth doing that.
All right, we've reached the end of our session. I see we've gone over time a bit. Thank you so much for availing yourself and for sharing your experiences with the boards of Selborne College. And I think what you have achieved is, and interestingly, you've all referred back to your teachers at school, And I think it's a testament to the character of the Selbornian, and also to the type of education that Selborne provides to boys, which is values-based education. So thank you for the wealth of experience that you've shared with the boys. And I think that they are better informed and better prepared, especially coming from people that have walked the same road as them. You know, as well as speaking about how different careers, you know, normally boys at this stage, especially those in grade 12, they are often unsure and panicking about what lies ahead. So it's nice to actually to see that there's no linear path to careers. I think that's what you've all alluded to. So thank you so much, and we've reached the end of the session.
Thank you.
Yeah, thank you.
Thank you.
And so just for last thing, thank you to the organizers, Mr. Parsons and Mr. Mapete. Thank you so much.